About the topic. Hello everyone, I am Ya-Sun Shu, the group leader for this project. Today, I am excited to present our final project, TSMC Stock Prediction, a hybrid approach using ARIMA and Kalman Filter. In this presentation, I will walk you through our motivation, our technical approach, the system design, and finally, the results we achieved. Motivation. First, let's talk about why we chose this topic. TSMC, Taiwan Semiconductor Manufacturing Company, is not just a local giant. It is the backbone of the global tech industry. However, its stock price can be highly volatile due to geopolitical factors and market demand. Our motivation was to create a tool that can look past the daily noise. We wanted to build a model that provides a reliable 30-day forecast to assist in medium-term investment decisions. To do this, we realized that simple prediction wasn't enough. We needed a way to smooth out the data. To tackle this problem, we proposed a three-step solution. First, data acquisition. We use the Y-Finance API to pull reliable historical data starting from 2010. Second, ARIMA modeling. We utilize the autoregressive integrated moving average model to calculate the trend. And third, Kalman smoothing. We apply a Kalman filter to the ARIMA output. This acts as a secondary layer to refined prediction and reduce statistical noise. ARIMA model. For our core prediction engine, we implemented an ARIMA model with parameters 5, 1, 0. The 5 represents the autoregressive term, meaning we look at the past 5 days to predict today. The 1 represents the integration, or differencing, which we used to make the stock data the Kalman filter. By setting a low transition covariance of 0.01, we essentially tell the filter to trust the underlying trend more than the sudden short-term spikes. We implemented this using the pykalman library in Python. Results. Here you can see our final result. The red dashed line shows the raw forecast from the ARIMA model. As you can see, it captures the general upward direction, but still contains some fluctuation. The blue solid line is our Kalman smoothed output. It successfully creates a stable trajectory, removing the noise while maintaining the accurate trend direction. This smoothed line is much more useful for identifying the true market sentiment over the next 30 days. Challenges and lessons learned. This project wasn't without challenges. Our biggest difficulty was parameter tuning. Finding the right P, D, Q order for the ARIMA model required significant trial and error. If the numbers were too high, the model would overfit. Too low, and it wouldn't capture the trend. We also learned that traditional models sometimes suffer from lag, reacting slowly to sudden market shocks. This taught us the importance of verifying data stationary before feeding it into the model. Future work. Looking ahead, there are several ways we plan to improve this system. First, we want to introduce deep learning, specifically LSTM networks, which are better at handling nonlinear patterns than ARIMA. Second, we plan to incorporate exogenous variables, such as the exchange rate or the U.S. Semiconductor Index, to give the model more context. Finally, we aim to automate this script to run daily and update a web dashboard. In conclusion, we successfully built a hybrid prediction model that provides a clear 30-day trend for TSMC stock. It demonstrates that combining classical statistics with modern filtering techniques yields superior results. Thank you for your time.